Hello friends, good morning. I welcome to you to this session where we are going to discuss today the GSM architecture and the interface. So my name is Niladri and I'm going to demonstrate all the network elements or the INIs in GSM architecture, plus we'll be discussing the interfaces used in GSM. We'll be going through the full form of each of these network elements, and hopefully you will enjoy this session because this is the basic for starting to start with GSM technology. And nevertheless, moving forward we'll be able to know all these network elements, and in the different session we'll be covering each of these network elements and their function exactly in the GSM network. And I think this is one of the robust and basic technology in telecom. So the telecom engineers, or for the RF engineers, or for the core engineers, or maybe for the BSS and O&M engineers, this architecture is very important to understand, including the interface, so that we can easily understand what the various network elements, what are their functions, and how do we manage the GSM network in terms of connectivity, interfaces, and the functional feature of each of these network elements. So let's go about it. To start with, I'll go with MS, which is nothing but the mobile station. From MS to BTS, we have interface, which is nothing but the air interface between the mobile station and the BTS, or the base transceiver station. Why it is called base transceiver station? Because it has a transmitter and receiver combined in this network element, which transmits and receives the information from the MS, and the MS also receives and transmits the information to the BTS via uplink and downlink. So the uplink is from mobile station to BTS, and the downlink is from communication from BTS towards the mobile station. So that's all about this BTS and mobile station and the interface. BTS normally controls the mobile station, and it shares the signaling channels and other data channels as per the requirement from the MS, and as per the services provided by the service provider or the service provider's network. From BTS to BSC, the interface name is ABIS interface, which is used for sending signaling and data and other information required by the BSC and the BTS correspondingly. So BSC is nothing but the base station controller, which controls multiple BTS or maybe one BTS. So there's always a limitation, like a BSC can handle how much BTS and how much TRX. The TRX is a network element which is used inside the BTS. So BSC has a specific guideline or specific range that the BSC can handle n number of BTS or n number of TRX as per the vendor specification. Let's say you are using a Nokia BSC or a Huawei or a ZTE or an Ericsson BSC, so they have different specification in the different releases, like how many BTS and TRX they support. And the interface between BTS and BSC, as I already told, it's a ABIS interface. From BSC to MSC, we are having A interface. MSC is nothing but the mobile station switching center, or the mobile mobile switching center, sometimes referred. So the MSC and the BSC connected via A interface. From MSC we are having various other core elements, core network elements, which is contained inside the core network. That's why I have subdivided the zones from MSC till the end. All these elements are called core network elements. From BSC and BTS are a part of the BSS, and The interface between mobile and BTS is referred as RF, or the radio frequency, or the RF zone. So this is important for the RF engineers, for BSS, BTS and PSC, and the further connectivity, maybe the OMC also. OMC is nothing but the operation and management center through which we are connected to the MSc and the BSc. So we can have information related to MSc and BSc in the OMC. Then for core network, we need to log in differently with MSc or the VLR or the HLR or the EIR and the AUC. So all these different network elements are connected via different interface to the MSc. Let's say from MSc to HLR, we are having the B interface, which connects MSc to VLR. VLR is nothing but the visitor location register. From VLR to other VLR, we are having G interface. So if we are having a secondary VLR or MSc, we can connect via G interface. Then we are having D interface, which connects from visitor location register to HLR, or the home location register. The home location register again connected with MSc via C interface. So this is all about the VLR, HLR and the interconnectivity from MSc. Moving forward, we are having this authentication center, which is connected via H interface with the HLR. And authentication center is basically used for authenticity purpose for a particular user. UV information also stored in authentication center. We are having other MSc connectivity from the parent MSc via E interface, and F interface is used between MSc and EIR. It is another network element which one is integrated within the MSc, which is called the equipment identity register. It's used for all kind of equipment information. So equipment identity register is connected to MSc via F interface. So this is all about the core network elements: MSc, EIR, other MSc, HLR, VLR, other VLR, and the authentication center. So that's how we have completed the GSM architecture, the interfaces and the network elements. Coming to the function, I'll just summarize and sort. We'll have a different session for all this individual network element and their functions. So MS is a mobile station, or the mobile handset you can say, which supports the GSM interface or the GSM technology. You can use mobile station to communicate with the GSM network. Then the BTS, which is nothing but a base transceiver station, which is used to transmit and receive information from and to mobile station. Then we are having BSC, which controls the BTS or multiple BTS functions. Again, BSC, multiple BSC are connected to MSc. MSc controls the BSC. So BSC is nothing but the base station controller, and MSc is nothing but the mobile switching center or the mobile station switching center. So again, MSc is integrated with many network elements like we discussed: the VLR, visitor location register, the HLR, home location register, the authentication center, the EIR or the equipment and identity register, and the other MSc and the other VLR. Apart from this, we are having OMC, or the operation and maintenance center, which connects to BSc and MSc. So with this, we have concluded the GSM architecture and the interface, plus all the network element name and their function a little bit. In the next session, we'll be covering individually all these network elements and their functions, and we'll also cover the GPRS architecture, which is again quite different than this architecture. So that's all for today. We'll be joining soon with a new and fresh topic on GSM or the 2G. and I hope you really enjoyed this session to watch, and I hope you understood all the interface and the fundamental architecture concept of this GSM or the 2G mobile communication system. And I have also explained what is a core network, what is a BSS, and what is the RF part. So there also we have some basic information to understand where this engineers exactly work and how. Like core engineers work in the core zone, BSS engineer works for BSA and BTS, and RF engineer for this BTS to mobile station connectivity mainly. So I think that's all for today's session. In the next session, as we discussed, we'll go with some new exciting topics. Thank you so much for watching. Please don't forget to subscribe to our channel and do like and share the videos. And last but not the least, don't forget to comment. Thank you so much for watching. Take care. Bye bye.